got a ship sailing 45 kilometers north, and then it changes direction and goes 15 kilometers east. We need to describe the displacement. So it's done that. The overall displacement is from the starting position to the final position. Now we're going to describe that displacement by a vector. A vector has magnitude and direction. Magnitude is like length. So what we can do is we can find, let's call the magnitude x. We can say x squared is 45 squared plus 15 squared. 45 squared plus 15 squared is 2250. So the magnitude is the square root of that, which is 47.4 kilometers to 3 sig figs. What about the direction? Well, if that angle there, theta, is the direction, then tan theta is 15 over 45. So theta is inverse tan of a third, which is 18.4 degrees. So the displacement is 47.4 kilometers on a bearing 018 degrees. So here we've got a parallelogram which has been split up, and I want you to imagine, it's not the greatest diagram, but that length and that length and that length and that length, and all these lengths are equal. So all of those are equal to A, and then all of these lengths from O to E and all these lengths here, they're all equal. So all those vectors are the same as E. What's the vector from O to B? The vector from O to B is that's A plus another A, so that's 2A. Notice that I've underlined this vector. If I don't underline it, it's a length. By underlining it, I'm saying that it's a vector. It's got magnitude and it's got direction. What's the vector from O to J? That's that one plus that one, so that's 2E. What's the vector from O to F? From O to F, I do OA and then I do AF. O to A is A. A to F is the same as O to E. So A to F is E. It's not right like that. I've got to underline the vectors. In textbooks they tend to write it in bold type, but we can't really write in bold type, so we underline. What's the vector from G to O? From G to O, there's G. We need to go back 2A and down 1E. So it's minus 2 in the 2 of A and minus 1E. What about O to G? Well, the vector from O to G, that's there to there, that's 2A plus 1E. So it's 2A plus 1E. So notice that OG is the same as GO, but the signs have changed because they're just going in the opposite directions. Finally, let's think about the vector NF. From N to F, there's N, need to go back 3 in the A and down 1 in the E. So it's minus 3A minus E. Now what about the vector from O to L? The vector from O to L, that's 2A and 2E. What about the vector from O to F? Two ways of doing this. It's clear that from O to F is halfway from O to L. So I could just halve all of those. Then I can also check it as well. From O to F, that's one of those, that's an A. One of those, that's an E. So OF is A plus E. But the point about this is that the midpoint, F, is worked out by doing half of O to L. So here we've got a more normal looking coordinate axis, and we've got various points, and let's think about the vector from O to A. The vector from O to A is 1 along and 2 up. So we can write it in the format 1, 2. It's also acceptable to write it as I plus 2j. I is the vector from is the unit vector in the x direction. J is the unit vector in the y direction. So I is that vector, and j is this vector. Now this is common accepted notation for what are called unit vectors. Unit vectors means the length is 1. So to go from O to A, we do 1 of those, and we do 2 of those. Notice that we underline the I and the j. What about the vector from A to F? Well, that's just 2 in the I direction. What about the vector from F to A? Well, it's minus 2 in the I direction. Notice that AF is that way, FA is that way, so that one is minus the other. The vector from E to F is minus 1 in the I direction, plus 2 in the j direction. What about the vector from C to B? It's minus 1 in the I direction and 2 in the j direction. Those two vectors are equal. That's because going from E to F is the same journey as going from C to B. The vector from E to A is minus 3 in the I direction and 2 in the j direction. What's the midpoint of EA? Well, it's formed by doing minus 1.5 in the I direction plus 1 in the j direction. What have I done here? I've halved the vector EA. Minus 3 becomes minus 3 halves. 2j becomes 1j. So the vector from E to A is minus 1.5 in the I direction plus 1 in the j direction. It's there. It's that point there. So that is at 2.5, 1. It's not equal to it, but the point is at 2.5, 1. So let's look at some more. The vector here from O to A is 2 in the I direction plus 1 in the j direction. The vector from B to C is 4 in the I direction plus 2 in the j direction. Now it's worth noticing that BC is double OA. If you double these numbers you get these. So the vector from B to C, which is this vector here, is double the vector from O to A. And these lines are parallel. If you look at the vector from O to A and B to C, they're parallel. The length of BC is double the length of OA, but the lines are in the same direction. And you can get that by noticing that BC is a multiple of OA. In this case it's double. Okay, what about the vector from B to D? That's 2 in the I plus 2 in the j. What about the vector from A to C? That's 2 in the I and 2 in the j. They're equal, BD and AC. B to D, that vector, is equal to that vector. Now to work out the length of a vector, or the magnitude of a vector, so looking at OA for example, we want the length of that line there. Well, it's Pythagoras, it's 2 squared plus 1 squared, and take the square root, so that's root 5. B to C, it's 1, 2, 3, 4 plus 2, so Pythagoras 4 squared plus 2 squared, take the square root, that's root 20. B to D is this vector here, so it's 2 squared plus 2 squared, 4 and 4, that's 8. And A to C is the same, root 8. Obviously 20 is 2 root 5 and 8 is 2 root 2.